Welcome everyone, I'm glad you're back. I'm so glad to see you guys back here. And today we are going to work together. We're going to slay a dragon called Complex Circuits. So we're going to solve this together in 5 steps. Make sure you have your calculator and your notes ready. Pause the video if you don't and grab your notebook and a pencil and a calculator and solve this with me, okay? So we want to find the current through the 8 ohm resistor. Let's take a quick look at this circuit. This is what we want to solve for, the current right here. Well, we know a couple of things. One, that the current there is not the same as the current here, coming down through this resistor. And that's not the same as the current going here, because like a river flowing, the total current is then divided up, because this is a split, or we like to call it a node in electronics. This is a node, and at a node, the current splits between the two. So we know that these two would add up to this amount, but we also know that none of these are equal unless it's some weird thing where they're both the same resistor, and then these two would be equal and half of that amount. So we want to go ahead and break it down step by step. The first thing we want to do is what we've been doing in class over and over. We want to solve for the total resistance between these 2 points. So we've done that before. Let's do it again. The first thing we want to do is break these two down into one resistor. Okay? I'm going to clear that ink because it's really ugly ink. Okay, so we're going to break that down. We've done it a million times. Go ahead and take this parallel resistance we want to solve for so that we get the equivalent resistance of just these 2 resistors in parallel. And we can do that by adding those 2 up and inverting, and we get 8/3 ohms, which is equal to 2.67 ohms. Now that gives you your parallel, and we still have to add that to the 2 ohm resistor over here. So we have the 2 ohm resistor plus the original one, and that gives us 4.67 ohms. So what we did was first we broke this one down, then we added it, plus this one here. So if you missed any of those class times, that's what we did. First we did this because any parallel, this is the equation you use, and any series you just simply add them up. Okay? So we added it, the equivalent up to the original one, and that's the answer for the first step. There's step 1. So step 1 was find the total resistance. Step 2, we want to find the current, the main current up here. Okay? So in order to do that, we can just use Ohm's law, because we know that we have a 10-volt power supply, and we have the current we want to solve for, and then the total resistance that it's going through. So we can use Ohm's law, 10 volts divided by what we just solved for, and that will give us the current just in the main part, which is 2.14 amps. Okay, step 2 is over. Let's do step 4, or step 3. Step 3, find the voltage drop across the 2 ohm resistor. Now in the lab, if you watch my lab, you could see that we measured the voltage across a little symbol for a voltmeter. A lot of times it's just a circle with a V in it, means voltmeter. We measured the voltage across the 2 ohm resistor right here, okay? So in order to calculate, which I told you we'd be calculating, in order to calculate the voltage drop across the 2 ohm resistor, we simply use what we already solved for, which is your current, and then the ohms of this, and solve for the voltage that way. So we have a voltage drop, which is equal to the current times the resistance. This is a rearrangement of Ohm's law. 2.14 amps times 2 ohms should give us 4.28 volts. Okay? So that's your voltage. If you had a voltmeter here, it should be reading that out on the voltmeter itself. We'd see that readout. Okay? Pretty nice. Now we know we have voltage drop here. Well, what does that help us do? That helps us solve for the voltage between point A and point B. Because if we have a voltage here, and if you watch some of those other videos, you can see that we can kind of relate it to a mountain. or at least potential energy of something going up a mountain maybe. If you have a 0 point, and then you hike to the top of the mountain, and say the mountain is 10 meters high. The short mountain, we like that. Okay, so then you go back down the mountain. You can walk down a different path down the mountain. Walk whatever way you want down the mountain, and you come back to 0. This is your 0 point. So this is like a circuit. As you go up, the battery is like going up the mountain. So that's adding the potential energy in. And then as you go around, you're going to lose it all. And when you come back to the 0 point, which is back on the negative side of the battery, is usually considered the 0 point, your 0 point, it's all going to be used up. So if that's true, then we can use this base equation here, that your voltage drop plus the amount of voltage drop on this other one here, but across this other side, is going to be equal to your total voltage. So since we already know the voltage drop, we can say that the voltage between point A and point B is 5.72 volts, just by simple subtraction, right? Great, so now we've found the voltage between this point, and we know that that's the same as the voltage between this point and this point. And if you don't know that, you can go back and watch my video of the lab of that. But basically, that this wire we look at here is no different than the node. That's why we call this point a node. You could go at an angle and connect these, and there would be no corners there, right? So basically, if you visualize it as actual wires, you can see that this point is exactly the same. So that's why we know that we can solve for this, and these points A and B are very important to us. So now we know that the voltage across the resistor is equal to 5.72 volts, and we can use that information with Ohm's law to solve for the current going through the system. So we have the 5.27 volts divided by the 8 ohm resistor, and that'll give us the total current that is passing through this leg of the system. So a lot of times when things break down, this is called a leg. Okay? So when you go around here, when I say leg, that's what I mean, this leg of the circuit. Okay? We have the answer. Awesome. So if you missed any of that, you're welcome to watch it again and try to actually calculate it through with yourself. Definitely, there's other supportive videos that go into more detail on things like this if you're finding this confusing. And we also have the original lab video that I did. I hope that you feel like we accomplished something and that you're not afraid anymore of dragons, because we just solved that one. We just slayed that dragon, and I hope to see you guys next time. I hope you are feeling connected through these videos, because I can't see you guys anymore, but I know you're out there and I remember all you guys, so I hope you at least feel a little bit connected to the classroom when we're making these videos. Thanks.